Okay, so it will be like this. We have 128 here, right? 64 here, and then 32, 16, and so on. And you might enter a binary pattern like this. Okay, now how do you convert this into denary? Is if there's 1 here, what we do is we add this 128 to the total, right? So they have used uh, instead of total, they have used a variable called denary number, because we are going to output the denary number. So denary number used like this: denary number equals denary number plus 128, right? That's how it goes. And if this bit is 0, we don't add the corresponding value. Now the thing is, these are 2 arrays. This is one array and this is another array, right? Now the binary pattern that you enter is treated as an array. It's a text. So if it is a text, you can access individual character using the index. So the index is going to be 0, 1, 2, like that. So if you take array A 0, that is 128. If you take array B 0, that is 1. Now in a loop, like a for loop, which goes from 0 to length of the array, right? You can take B0 and check this one. If it is 1, what you have to do is you have to add A0, which is 128, into the total, right? Then you go and check the next bit. It's 0, so we don't add this. Next one, it's 1, right? So B2 is 1. If B2 is 1, what you do is you add A2 into the total, 32. That's what we do, right? Normally, like, we convert this by adding these positional values right above ones, right? So 128 plus 32 plus 16. That's how it goes. So you have to visualize that first before you attempt this. Okay. Then the second part is analyze the variables that they have given. Okay, they have given already. They have given the placeholders. You can see there are 8 bits here. So 1 to 128. Then binary pattern equals double quotes, which means they want you to add it as a text, as a string. That's why it's blank. Denary number equals 0. Now that's the one which will be output. So that's like the total, right? Then count is 0. So count looks like we need count to go through each and every binary digit in the for loop. Okay, so do a bit of analysis and then start, right? Okay, first I'm going to do it. First you watch and then you do it on your own, right? After the class, and send me a screenshot, then I can double check, right? I'll be posting the video as well. Okay, so I'm going to put a comment here. First I'm going to input the binary pattern. You both can hear me clearly, right?
Yes.
Yes.
Right. Binary pattern. Okay, what should you do? I should use this variable binary pattern. Okay, equals no int because it's a text. So input, enter your binary pattern. In the exam, you try to complete as much as possible, right? Because you get part marks. Don't just leave it thinking that it's difficult, right? At the same time, don't waste a lot of time. Also, like if you think like, okay, this is too difficult, try your maximum and then quickly move to the next one. That's why you should have an idea about the time, right? So just have that idea, like 2.25 into marks, right? You're not allowed to use a calculator, but you have the calculator in the computer, right? So just keep an eye on the time. Okay, so that's input. Then what you have to do? They say we have to validate. If you read the question clearly, you would see that we should validate this for 8 bits. So validate. Next is validate. How do you validate? We need to ask the user to enter the bit pattern again and again, as long as the number of bits is less than 8 or the number of bits is greater than 8. Okay, so think of now when you're validating, you think of the incorrect situation, right? Not equal to 8, right? Because we need to validate as long as it is wrong. So while that's as long as len of binary pattern, that's what user has entered, is greater than, sorry, less than 8. So as long as the length of the binary pattern is less than 8, or because you can't have both conditions and, right, you can't have the binary pattern less than 8 at the same time greater than 8, right? So it should be O. Len of binary pattern is greater than 8. As long as it is less than 8 or greater than 8, what do you have to do? You have to ask the user to enter it again. So this input has to be added again. Okay, so enter your binary pattern again. Let's make it a bit more user friendly. Let's say there are no 8 bits, right? Enter your binary pattern again, something like that. Okay, so validation is done. Next is to convert. Okay, well, the conversion part is the tricky part, right? But if you do a small analysis like this, it's pretty easy. Just visualize the technique first. Right. As I told you, we need a loop here, right? We need to start from here, index 0, and go up to the length -1. Okay, so let's have a for loop. Right, now we need a total, right? Total to convert this and output. That's a separate thing. But for the loop, we need a variable to go through the index, right? So they have given, I can't use index or anything because they have given, that is count. So use the variables that they have given, right? So for count in range, right, starting from 0 to you can even give 8, because we need to go from 0 to 7. Why? 0, 1, 2, 3, 4, 5, 6, 7. Or else you can put length of binary placeholders or anything, right? Or binary pattern, because by this time the binary pattern is validated. It should have 8 characters. You can take the length of this or the binary pattern, or else simply put 8, because we need to go up to 7. All right, just a minute. All right, what should you do? We need to first check whether, now we are reading, right? We are reading each binary number. We need to check whether it is 1. If it is 1 only, we take the positional value or the placeholder value and put it to the total, right? So we need to check whether it is 1. How do you check? If binary pattern, now I told you that it's a text. In a text, you can access individual characters by treating it as an array or a list. So binary pattern, square brackets, inside the square bracket I can use the count variable, because count starts from 0 and goes up to 7, and I check whether this equals to 1. I need to use double quotes because it's a text. Okay, if that is 1, what do you have to do? The total, where's the total? Total is this binary number, right? Because we are outputting the total as the binary number, right? If there's 128, we add that to the total. If there's 132, we add that to the total, and ultimately we output the total. So for the total, they have used a variable called binary number. So I'm going to use binary number equals binary number. I had to use it twice because I'm going to update the current value of binary number. Right, it's like x equals x plus 1. Binary number equals binary number plus, right? What should you add to the total? You should add uh, the positional value of the first array, right? Same index, right? You check the index 0 in the second array, and now you are adding the index 0 value of the first array, right? That is 128. Okay. Binary number. So what is the array? Binary placeholders. Okay. Square brackets, because it's an array. Right? Inside that I should have count, because count index is the same for the first array and the second array both. Okay, so we are starting with 0, right? We check the 0th index of binary pattern. If it is 1, we read the 0th index of binary placeholders array and put it to the current total. That's what we do. Then we go to the next one, next one, next one, next one, right? And after the for loop, right, we have the total, which should be displayed as the binary number, right? So print binary number. Right, let's print it like this. Print binary equivalent of, comma, what should I display for the binary pattern? It's binary pattern, this one. If I want to show the binary pattern, comma, space is, comma, what's the result? That's the result. Result is binary number. Simple. Okay. Right, now let's test it. Don't forget to save it as finished first before editing. Save it as Q4 finished. Okay. Right, let's run it. For some reason, it takes some time for me to run this. Okay. Let me create. Okay, let's run it. Binary pattern, right? As I told you, to test, you can put all ones. Okay, first of all, we'll check whether it is getting validated, right? 1, 2, 3, 4. Okay, fine. Gets validated. Let's put ones or a binary number with more than 8. 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10. Great. Let's put all ones, all 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. What should be the value? 255. There you go. Right? Let's try a different one. Let's try 0, 0, 0, 0, 1, 1, 1, 1. They should be 15. Works perfect. Did you understand? Is that clear?
Yes, sir.
Okay, great. So I will share the screenshot and I will share the recording as well, right? But you have to do it on your own and send me the screenshot. Then only I can confirm that you understood and did it on your own. So make sure that you do it, right? So get the advantage of these just a minute. Okay, So get the advantage of these few days, right? Because there's a great advantage. You have 30th, first, right? So many days, and we'll try to do maximum number of papers, right? Tomorrow also I'm having a. Here's the screenshot. All right. Let's see whether we can do the next one. 11 marks there. Open Q40B in the code editor. Describe the purpose of the program. Right. Now that's a different question. No? They have given the program and they're asking the purpose of the program. Okay, just open it. Q4B. So nothing to do. Just open and see what happens. Good enough. Okay, for this you can first run. The original word is random and the new word is modern. No, it is not. The original word is repaper and the new word is repaper. Yes, it is. Okay. So here what has happened is random is reversed, right? See? Modern. And it says no, it is not. Still is not clear why they do it. Then here the original word is repaper and the new word is repaper. Oh, both ways it's the same, right? Yes, it is. Okay, so now it's a bit clear. Looks like it's looking for the words that can be reversed and still give the same word, right? Isn't it? Is there a name
Yes,
for it?
sir.
Is there a name for these kind of words?
Not really, sir. I don't think there's a name.
Mm-hmm.
I'm not sure of a name, but
You know, in the mark scheme, they have given a word called palindrome. Heard about it?
no, sir. But there's one for numbers.
No, right. They have said palindrome. Who can remember that? Okay. So if you look at this now, see, like you don't really need to understand the code here. Right? If you just look at the output, you understand what happens, right? So let's quickly see how it actually finds it out, right? But that's certainly not needed in the exam. We'll be wasting time. Def check word p word, okay, and then we are sending the word, so it will be taken by this parameter p word. New word blank, count length of p word -1 while count is greater than 0. New word equals new word plus p word count. Okay, so p word count means uh, it is taking the last word. Okay, I mean last character, right? Notice that the count starts from uh, the last character, length of word -1, because it starts with 0, right? So 0, 1, 2, 3, 4, 5. So the count starts with 5 and goes backwards. What does it do? It reads the last character and merge it, concatenate. Plus is concatenate to the new word. So the M will be concatenated first. Next O will be concatenated. Then D will be concatenated. Pretty easy, right? Then the original word is P word and the new word is new word. So it prints the original word and the new word, right? If the new word equals P word, yes, it is. Oh, obvious, right? Else, no, it is not, right? So it's good to understand. how they have done it, right? Did you understand how it is done? It reads from the last character and comes backwards to the zero character. That's why the count is starting with length p word -1, right? For example, in this one, it starts with the fifth letter, and the fifth letter is merged or concatenated to this new word. So the m is added first. Next, count equals count -1. That means we are reading O. O is added to the new word. See, MO. Next, D will be added to the new word. So D comes there. Next, N, next A, next R. Right? As long as count is less than or equal to 0, we continue this. Okay, when count is -1, we stop it. And then what we do is we check the old word and the new word. That's all. Understood? Simple, right? Okay. But to answer the question, you don't really need to understand the code. You can just look at the output. Okay. So how do you write the answer? Any questions? Did you understand the code, the technique? Yeah. 3 of you. Adashana, Binuki, Rasi, did you understand the code, the technique?
Yes, sir. So, sir, the answer should we write it like the program identifies letters that can be reversed exactly the same and produce the same output when it's reversed as well?
Same output in the sense? What do you
Like
mean?
the same word, then
Yeah,
it's
yeah.
reversed.
It checks whether two words, I mean, it checks whether an original word uh, gives the same word when it is reversed, when the letters are reversed, right? It checks an original word, right? Okay, let's put it this way. It checks whether an original word uh, gives the same word. You don't need to like by heart the, I mean, you can put it in different ways with the same idea. It checks whether whether an original word gives the same word when the letters are reversed, right? But you have to be very specific. Okay. Uh, Now the problem is, according to the mark scheme, this gives only 1 mark. Okay, this gives only 1 mark. The other mark is given for the output, right? So that's crazy. Right? We think that this is sufficient, but they look for another mark, right? That is given for. Then it outputs a message.
But sir, the question asks us to describe the purpose of the program also. So
Yeah. But
they don't specify
yeah, but see the
just
mark
to give
scheme.
the output.
This is the problem, right? Mark scheme has given 1 mark for this, and the other mark is for this, right? Then it outputs a message to, we can say to inform whether the two words are the same or not. Okay. So these words that give the same word when the letters are reversed are called palindrome. Palindrome. Okay. Right. Binuki, did you understand the technique? Now, this is what you should train yourself for, right? The technique. If you get the technique, the way you should solve the problem, then visualizing the technique is the answer, is the solution, right? We can visualize the technique and keep it in your mind, then it's pretty easy. Okay, Binuki, did you understand the technique of reversing this?
Yes, sir.
Rasi, did you
Yes,
understand
sir.
the way they reverse it?
Yes.
Yeah, because understanding this will enable you to solve another problem. Right. So what was the technique? We started with the last letter of the original word, and then we started merging or concatenating it into a new word. Right. So the last letter was added first. Right. So when concatenating, what happens is it'll join. M will be, I mean, M will be joined the blank new word first, then O will be joined. So M, O, then D will be joined. That's what happens, right? Even if it is on numbers, they won't get added, right? Uh, unless they are integers. If they are, um, you know, text or strings, they will be concatenated. So it will be like one, 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 like that. So that's exactly what happened in the previous one. That bit stream was a text, a string. Those were not numbers. Right, so the fourth question is done, and we are left with the fifth question, the last one. Okay, I don't know, the ones who are not attending the class, I don't know how they're going to understand this. And the last one is going to be much more advanced, and 20 marks given, 20 marks. Right, okay, so you better not try it. I mean, you better try this in the class, because then you get that exam tension, right? So don't go through the question before the class. We'll do it during the class tomorrow. Okay, tomorrow also evening.
Okay, sir.
What you should do is practice question number 4 again and again today, right, on your own. Right, first do it by looking at how I did it, right? But there can be different ways. Try to put your own knowledge and everything, and try it on your own. That's the important thing. You have to train your brain. Okay, then see you tomorrow.
Thank you, sir.
Thank
Good
you,
night,
sir.
sir.
Thank you, sir. Good night.
Right.